So let's talk about identifying slope from a table. So an XY table is one way we can represent and organize the X inputs and their corresponding Y outputs of a linear function. So each of these X and Y pairs represents a coordinate point that when graphed would fall on the line of a function. So in this case, we would have the coordinate point 0, 2. In this case, we'd have the coordinate point 2, 6. In this case, we'd have the coordinate point 4, 10. And then this one is a little bit of a mystery because we don't have both of our X and Y's. But it's pretty clear to see that these inputs and outputs are just coordinate points. So while not all of our linear tables are going to be proportional, whether they're proportional or not, we will find that the change in X values will always have a constant rate. And our change in Y values will also always have a constant rate. Let's look at those here. Let me erase my coordinate points. For this table, so here, let me start doing some color coordinating. I will say that my change in X are going to be blue. My change in Y will be red. So for my X values, from 0 to 2, I grow by 2. From 2 to 4, my X values are increasing by 2. From 4 to 6, my X values are increasing by 2. So my change in X is 2. What's happening for my Y's? From 2 to 6, my X value is increasing by 4. From 6 to 10, my X value is increasing by 4. So since this is a linear situation and our change in Y has to be constant, that means that I can find the corresponding Y. So when X is 6, that means Y has to be 14. This is what I mean by that it needs to be a constant rate of change for our X's and our Y's, even if it's not proportional. And this is how we identify the slope. So when we were calculating the slope of a graph, we were dividing the change in Y and the change in X between any 2 points. We're going to do the exact same thing for a table. So we can pick any 2 XY pairs and we can calculate the change in Y and the change in X. So since I found out, or we found out I should say, that this point is 14, let's start with some faraway points. Let's start with these 2. So let's look at 0, 2 and 6, 14. My change in X here was I added 6. My change in Y is I added 12. So we would write that as change in Y divided by change in X. So in this case, we've got a denominator of 6 and a numerator of 12, which means that our slope is 12 divided by 6, or 2. So we would say the slope of this line is 2. And just to prove that we could really pick any 2 points on this table to calculate our slope, let's erase this and let's pick 2 different points. Let's pick these 2 that are closer together. So let's look at the point 2, 6 and the point 4, 10. So let's go ahead and erase this too. So here, my change in Y, from 6 to 10, I added 4. So my change in Y is 4. And my change in X is 2. So once again, we see that my slope here is 2. So the slope of this situation, if we were to graph this as a line, this line would have a slope of 2. And just for giggles, a bonus, what is the y-intercept? Well, our y-intercept is where our line crosses the y-axis. So where our line crosses the y-axis. And while we don't have a physical line to see, what we also know about our y-intercept is where x is 0. So x is 0 right here, which would mean that when we graph this line, that would be our y-intercept. All right, let's try another one, identifying the slope from a table. So again, I'm going to look at my change in y divided by my change in x. Let's see what we got going on here. Start with my y's. Again, we can pick any 2 points. I'm going to pick my furthest away points. Well, let's start with some observations. Sorry, I went a little too fast. Let's start with some observations. I can see that my x values are growing by 2. My x values are growing by 2. My x values are growing by 2. And I can see that my y values are right here. We see a decrease in 0.5. So since this is linear, that means that what we're going to need to see here is a decrease in 0.5. And actually, I made a mistake over here. Let me erase this. This one got tricky. Between 8 and 12, that isn't a change in 2. That is a change in 4. Sometimes these tables are a little bit tricky. But we could go ahead and fill this in a little bit, and we know that, well, 7.5 minus 0.5 is just going to be 7, which means that when my x changes by 4, what's happening to my y's is it's decreasing by 1. So this is linear. But now let's go ahead and pick a couple points and calculate our slope. Once again, I want to start with my farthest 2, just for giggles. Sometimes it's more fun for me. So I'm going to look at my change from the point 4, 8 to the point 12, 6. So altogether, my change in x from 4 to 12 was 8. So my change in x, I've got myself 8. I added 8 there. And my change in y, from 8 to 6, I subtracted 2. So my change in y is -2 between those 2 points, which when simplified means that I have a slope of -1/4. So working with a negative slope, which means my line, if I were to graph this, would be decreasing at a rate of 1/4. And we can look at that with some closer points. Let me erase some of this because it's getting a little messy in here. And we can look at 2 closer points. Let's look at these first 2 that were given to us. Here, my change in x is I added 2. Here, my change in y is I subtracted 0.5. So I could write that as a change in -0.5 divided by 2, which also simplifies to -1/4 or -0.25 if you prefer your decimals. So there's our slope. Go ahead and try the practice problems now. Let me know if you have any questions.